Hamid Ali is going to be presenting his Honk Honk, Please Don't Hit Me.
Hello everyone, I'm working on development of smart e-scooters that have the technology to protect the riders from crashes. E-scooters are great last-minute micro-mobility vehicles and actually they're very fun to ride. But as you can imagine, they're very vulnerable to crashes. Let's say you're in a car and you have a small fender bender accident. Nothing really happens to you. But if you're riding an e-scooter and you get hit by a car, the accident might be fatal and you might get severely injured. So what is the solution? One solution to this problem is to equip all the cars on the roads with a technology that could automatically spot the e-scooters and avoid collisions with them. But it will take many years or decades for such a technology to get incorporated with all the cars on the road. We cannot wait that long. So our solution to this problem is to develop a technology that could be used right away on today's e-scooters. We equip today's e-scooters with very low-cost sensors, and using these sensors, we detect the vehicles around the e-scooter and track their trajectories. We can predict their trajectories, and if a collision is going to happen between the e-scooter and the e-scooter will sound a loud horn to alert the car driver about its presence and make them aware about the dangerous situation. As you can imagine, we are using very low-cost sensors. For example, to track the vehicles behind the e-scooter, we use a low-cost laser sensor that measures the radial distance to the vehicles behind the e-scooter. But the challenge comes in when we want to find all the trajectory variables. Knowing the radial distance to a car behind the e-scooter is not adequate to accurately predict the accident. What we need to know is the lateral distance, the longitudinal distance of the car, its orientation, and the velocity of the car. These are all required to accurately predict the accident. So what we do is developing estimation algorithms to accurately estimate these variables using the limited information that we get from these low-cost sensors that we have on the e-scooter. Another goal that we have in this project is to monitor the traffic in front of the e-scooter using a camera to detect the vehicles and a laser sensor to measure the radial distances. Again, we use our estimation algorithms to estimate the trajectory variables based on these limited information that we get from the sensors to accurately predict the accidents in front of the scooter and protect the rider before it happens by sounding a loud horn. This is a very exciting project, and we are hoping that the technology becomes ready in the next year or two and we can demonstrate it. And we are hoping that our technology could protect the e-scooter riders on the road and they have a better experience while they're riding e-scooters. Thank you very much for listening to me.